welcome you all again for grade 11 economics. So we are in chapter 3, which is called as organization of data. Right. Already we have discussed two chapters in statistics for economics. One is called the introduction. The first chapter we have discussed introduction. What is economics, what is statistics, and how statistics is related with economics. What is the use of it we discussed in chapter 1. In chapter 2 we are dealing with collection of data. What are we talking? What did we talk about? We spoke about collection of data. How do you collect data? What are the methods? What are the sources? What are the modes? Everything we have discussed. Now we are in chapter 3, which is called organization of data. That is, we have completed the collection of data. The next step is that we have to classify and organize the raw data that we have collected. With the help of this function, this particular task, we'll be able to use the data collected in a more feasible way for the other analysis. That is what we are doing with organization of data, and according to organization of data, we spoke about classification of data. In various ways, the raw data is classified. What are the various ways? We had chronological classification, spatial classification, and then we spoke about quantitative classification and qualitative classification. As of now, we are discussing about what is meant by frequency distribution. Right? In the previous video session, we have discussed what is meant by frequency distribution. How are we going to deal with it? And frequency distribution, what is that? It is a comprehensive way to classify raw data, and especially it talks about the quantitative variables. In frequency distribution, we discussed about what is meant by class, what is meant by frequency, class limit, upper class limit, lower class limit, class mark or class midpoint, and all those things we have discussed. The graphic representation of a frequency distribution is called as the frequency curve. In frequency distribution, further we have discussed how to frame, how to prepare a frequency distribution. For this preparation, we need to answer a few questions. We need to decide on some attributes about the frequency distribution. The first thing was, should we have equal or unequal sized class intervals? That we discussed. Then we went on like only for two reasons we'll have unequal sized class intervals. That is when the range is too high, values are like of so much of differences. Okay, then we'll go for it. And when there are a large number of values which will be concentrated in particular limit, then we will go for unequal size class intervals. For other cases, we'll be going for equal size class intervals. After deciding this, next we have to decide on how many classes should we have. Usually, basically, we'll have in general 6 to 15 is the limit. Okay, minimum 6 classes and maximum of 15 classes is what we'll do. But in other cases, in equal size class intervals, we'll decide it based on the range. What is the range? It is the difference between the largest and the smallest value of the variable given. Next question is, what should be the size of each class? It is 10 or 20, we decide, right? We are going to relate it with the how many classes should we have. So based on range, once you find the range, you will be able to decide on how many classes you should have and what should be the size of the class limit. Okay, size of each class. Then we have discussed about the upper class limit and lower class limit. We say that the size of each class is 10, which should be the upper class and which should be the lower class is what we are discussing now. There are two kinds of class intervals, inclusive class intervals and exclusive class intervals. Inclusive class intervals means both the lower limit as well as the upper class limit are added into that particular range, particular frequency. You take it into account. Whereas exclusive class intervals means anyone, either the lower class limit or the upper class limit will be taken into account related to this particular topic. Fine, children. So how are you going to decide whether you are going to take the lower class limit or you are going to take the upper class limit is what we have discussed. In case of discrete variables, it was fine. We are able to, it's just jump, so we can go either with inclusive class or the exclusive class. Whereas in case of continuous variables, it is almost always inclusive class intervals. Talking about inclusive class intervals, we have some confusions in inclusive the example of continuous variable. So continuous variables means what? You will have even decimal values. Any numerical value can be taken into account of continuous variables. Whereas discrete variables means you have to use a proper value that should, added or multiplied like that. A proper jump should be there. Okay, fine. So we are going to start our day with the frequency distribution, like how you will decide the upper class limit and lower class limit for a continuous variable. Okay. Organization of data. So how we are going to deal with continuous variables. So here we have an example of income. Okay. Let us take the same example for better understanding. Okay. So we have income and here we have number of employees. Fine. So what did we define? 800 to 899, 900 to 999, 1000 to 1099. Right. Then 1100 to 1199, 1200 to 1299, 1300 to 1399. What are we using? Inclusive class intervals we said. Inclusive means both will be taken into account. That is why we are using this kind of status. Since we need how many? We have got 6. Now we are going to mention the number of employees. So here we have 50, 100. Then how much we have? 200, 150, 40 and 10. So the total number of employees are 550. Now this is your continuous variable. When you say continuous variable, even decimals we can use. Now we need to have an adjustment in the class interval. Everything is fine. The size of class is 100 only. The difference is 100. 899 minus 800 will become 99. Okay, 999 minus 900 will become 99. So it is same. The class interval or the difference is the same, 99. But after 899, we find like this difference is there, right? 900 minus 899 is there. The difference comes as 1, which is called as gap. How do you call it? Gap. A close observation of the inclusive method will show you that the variable income, the difference between these two, that is the upper class limit of the second class and the lower class, sorry, the upper class limit of the first class and the lower class limit of the second class, you should find the difference. So when you find the difference, it becomes 900 minus 89, and whereas this 1 is called as gap. The gap will be there. Right? What is it? We find gap or discontinuity. It is not the same number. It is a different number. So we call it a gap, the discontinuity. How will you find it between the upper class limit of the previous class and the lower class limit of the next class? So how are we going to adjust it is what we are going to do. What are we going to do for next? Adjustment in class interval. So this gap comes, and how do you find this gap? The difference between the upper class limit, okay, of previous class minus the lower class limit. There are various steps. Okay, first step you need to find the gap for the adjustment. How will you find the difference between the lower limit of the second class So second thing, divide this value by 2. Whatever answer comes here. For in this example, we have got the answer as 1. In the next example or in another data, we may get it as 2 or 4 or 7, whatever it is. So whatever answer you get, you divide it by 2. So here 1 divided by 2 becomes 0.5. Okay, that is your second step. Subtract the value obtained here. Whatever you have obtained, here we have marked as 2, right? That is the second point. Obtained from lower limit of all classes. So what you have done, you have found the gap, the adjustment that is 0.5. From the lower limit, you have to deduct that 0.5. So when you deduct, how will this table change as? Everywhere you are deducting 0.5. So 800 minus 0.5 will become 799.5. Same way, 900 minus 0.5 will become 899.5. Similarly, you are going to do in all the cases. Okay. What you are doing from the lower class limit, you are deducting the value that you have obtained. For every example, it differs student. For every frequency distribution, it will differ. In this example, we have got 0.5. Okay. So what did you do as the third step? Deduct this value from the lower class limit. Next step, what you are going to do? Add this value to the upper class limit. What you have to do? The same value should be added to each upper class limit. How will you do it? 899 plus 0.5, 899.5. 999 plus 0.5, 999.5. Similarly, everywhere you add 0.5. Now when you compare, this is the adjusted frequency distribution. Now if you compare, how it happens? 799.5 to 899.5. Next, 899.5 to 999.5. There is continuation. Right, and this happens only with continuous variables because we can have decimal values. Whereas in discrete variables, definitely you cannot have because we cannot have the decimals. And there should be proper jump. Here there was no jump at all. It was all continuous. Alright children, this is your adjusted frequency distribution table. Fine. What are we going for the next step? 4 steps completed. This is how you have adjusted. What do you do next? After adjustment, you have restored the data in such a way. I have made arrangements in the same data, but you will be doing 2 different data. Next, you will be finding the adjusted class mark. How did you find class mark? You found the upper class limit plus lower class limit divided by 2 was class mark. That is the class midpoint. Same thing what you are going to do. You are going to find the adjusted class limit. Okay, adjusted class mark. How will you find it? Same, adjusted upper class limit plus adjusted lower class limit divided by 2. So for this particular thing, how will you find? You will make it as 799.5 plus 899.5 divided by 2. This value will become the adjusted class mark or the midpoint of the particular class. Previously also we have done the same, but now what we are doing? Adjusted values obtained. Fine children, so how is that adjustment done and for what purpose it is done? There was a little gap. What is the gap? How will you find the gap? The first step in the adjustment in class interval is itself the gap. How do you make it? By finding, by deducting, by finding the difference between the upper class limit of the previous class and the lower class limit of the present class. Alright, upper class limit of the class minus the lower class number of the second class, you will get the value. You have to divide this value by 2. Okay, whichever value comes, you have to deduct, you have to subtract this value from all the lower class limits, and similarly you have to add the same value with all the upper class limits. This is how you find the adjustment in class interval. After doing this, you rearrange the data accordingly. You will not have any change in this side, but you will have change only in the class given. Fine, children. And then what do you do next? You find the adjusted class mark. How do you do it? Adjusted upper class limit plus adjusted lower class limit divided by 2 is your adjusted class mark. Fine, children. What should we do next? This we have done. The final question that should be answered. We said that 5 questions should be answered for preparing a frequency distribution, and we have answered whether it should be equal or unequal size class intervals, then the number of classes, how many classes you have to have, then the size of each class we have answered, then how do you decide the class limits, upper class limits and lower class limits, and finally we spoke about how should we, final question is how should we get the frequency for each class. We are saying, no, this is the frequency, that is the class, this is the frequency, this is frequency and this is the class. How do you get it? How will you fix, how will you find the frequency for each class is the next question that we are going to answer, and with that we will be able to complete the frequency distribution. How are we going to do it? We are going to just count it. In terms of counting also, we might make some mistakes. So we are going to have some tools and techniques for counting, for calculating the number of frequency that has to be used here. Okay, how will you decide on the frequency is what the next question that we are going to answer. What is the next question? How should we get the frequency for each class? This is the 5th question or the 5th determinant. What is that? Frequency of an observation means how many times, okay, number of times the observation occurs. Okay, number of times the observation occurs. In the example when we discussed marks, so how many times 40 to 45 came, that not we have taken into account. Right, how many times 50 to 60 came, that all we have counted. So how do you do it? You find this class frequency using tally marking system. What are we going to talk about now? We are going to use the tally marking system. So this slash is mentioned as a tally mark. Fine. So how do you do it? Usually some people they put a straight line also, but the right way is doing this way. So for example, when you have data, okay, you're just calculating the height of students or the weight of students, so 10 kgs to 20 kgs, how many of students are there, that we are going to calculate. So how many students are here? We have 110, we have 12, we have 15, we have 17, okay, we have 27, we have 35. This is the data you have got. Now you need to calculate how many number of frequencies, how many times this particular observation has come. 10 to 20, so 10, that means 1 dash. 12, that also happens to come between this frequency, this class of it, so another dash. Third is 15, same class, so I take that into account. Fourth is 17, that also I take into account. 27 will not fall in this class. 35 will not fall in this class, so I am not counting it. Another 3 I have got. 11 falls in this class. Fifth time, what do? I don't draw another line, but simply I strike it like this. Okay, fifth line should be 10 into 5, 50, then remaining whatever surplus in the revenue count. Easy for us to calculate. This is how we usually calculate the frequency. Right? What is this mark on? This one is also, this one is called as tally marking system. And in the we input slash for each time an observation occurs, we input on one dash. For the fifth time, we will cross it so that we will calculate it as 5. Clear, children? Shall we go to the next step? The next step is talking about laws of information. Fine. So far we have discussed about how we will calculate, how we will determine the number of the frequency. How we will determine the frequency for each class by using the calculation of number of times an observation occurs in the data, in classification of data or in writing data. Through that only you will calculate your frequency. One good technique for that is using your tally marking system, where you will use the symbol each time an observation occurs, and final time, the fifth time you will cross it so that you can add it or you can calculate it as 5. Fine. So these are the various things to decide when you prepare a frequency distribution. That is, whether it is equal size or unequal size, what are the number of classes, okay, size of class, what is the class limit, upper class limit, lower class limit, adjustment in class interval, and then finally we spoke about how do you determine the frequency of each class. What is the next important thing that we are going to discuss? Is we are going to talk about laws of information. Now let us have this example as this. Okay, we have this information as this. Let us talk about the next topic, which is laws of information. Once you calculate the frequency, what happens? You take frequency for everything. You talk about the frequency only for every calculation. Or you find the class mark. Here you find the class mark. That is, what will become the class mark? 10 plus 20 by 2, 30 by 2, which is 15. So the class mark is 15 and the frequency of that particular class is 7. You will take only this information. You will not talk about this. You will not talk about 10 or 12 or 15. 10 to 20, anything can be there. I have 7 frequencies, 7 observations in 10 to 20 means, is it 11 or is it 13 or is it 17 or 2 times 20 or 2 times 17 or 2 times 15, which is not given, nothing is mentioned here. Fine. So this is called as laws of information. Once you have prepared your frequency distribution, once you have completed your classification of data, then there is the probability of laws of information. What is it? In classifying raw data, so much is gained by summarizing. In summarizing, what is it actually? It is summarizing. You are just counting how many times an observation has come, but you are not having all the values in a class. All the values in the class, these are the values given in a class. Does everything get importance? No. They are calculated to be equal to 50. You will not talk about this. Class mark only you will consider. You will not calculate the values which are lesser or higher than the class mark, but you will talk only about the class mark and the frequency. Thus, we say that when in case of frequency distribution, there is a probability of loss of information where you don't take into account the actual values of the observation. But in case you want to make more reasonable data, you have to go for further analysis. There is no other way. You need to summarize the data, you need to classify the data and prepare a frequency distribution where loss of information, even though it is a demerit, you cannot avoid it. There is no other way. You have to go for classification of data. Otherwise, the raw data cannot be taken up for further analysis and study. Fine, children. What are we going to do next? We are going to talk about frequency distribution with unequal classes. Frequency distribution here they have after 0 to 10, okay, 0 to 10, what is the class? It should be 0 to 10, 10 to 20, 10 to 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. These are the classes that they have given. But in earlier, what did we talk about? There were too many values concentrated in particular block. Like for example, if you take the log 40 to 50, this range was there, no? There were around 45 people. Then here 55 frequencies. Okay, here 65 frequencies. When so many are there, somewhere it is not distributed properly. Right, somewhere it is not at all distributed, where somewhere it is more, it is highly spread. How do you take that particular thing into account is what we are going to discuss. Okay, how are we going to take it into account? We are just going to divide this also into unequal classes, that is from 0 to 10 to 30 to 40 it is same. This 40 to 50 is there, no? We are dividing it as 40 to 45, 45 to 50. Then this class 50 to 60 is also divided as 50 to 55, 55 to 60. So when you divide it like this, the other classes they remain the same with the same class width of 10. Whereas these classes are only divided and the class width comes to 5. For what? For better understanding. So that the frequency becomes less. When the frequency becomes less, it is easy for them to study. That is why we are using it. Okay, so they have given a table 3.6 and table 3.7 should be compared, children. Then only you will be able to understand this particular example or this particular question about frequency distribution with unequal classes. Why are we having it? Because many of the values are segregated or concentrated in that particular area where here it is less. So they have divided it for further reference and easy understanding. In that case, what you have to do? You have to find the class mark, because we studied that with the help of class mark only we can go for the further analysis. What is the class mark? How will you find the class mark? By adding the upper class limit and the lower class limit, dividing it by 2. So here it remains same 40 to 50, then the class mark is 45. Whereas here it will change, it will differ. Right, children? These observations in these classes deviated more from their old class mark values and their new class mark values. Thus, the new class mark values are more representative of the data in case or in classes than the old values. In the old values, the data is 45, the class mark is 45, 55, 65. Whereas here it becomes 42.5, 47.5, 52.5. So which one they will take for analysis? The new class mark will be taken for analysis. So now when you draw a frequency curve, what is a frequency curve, children? The graphical representation of a frequency distribution is called as a frequency curve. What do you do with it? When you do this, it will also change. The class marks of the table will be plotted on the x-axis. The class marks will be plotted on the x-axis and the frequencies will be plotted on the y-axis. So you can find the change in the curve. How it changes, how it was for table 3.6 and how it is applicable for table 3.7. Alright, children. What is the next thing we are going to study about? We are going to talk about frequency array. What is a frequency array? So much time we are discussing only about continuous variable. So how are we going to do it for discrete variables? Because we are going to have only the jumps. Right, continuous variable case of discrete variables, we call it a frequency array. How it works there? It takes values and it does not go with any intermediate functional values. It has only jumps. In that case, how will you have the frequency array? They have the example here where size of the household is given. Size of the household means what? How many people live in one home, one house. So it is given as 1, 2, 3, 4, 5, 6, 7. Is there any median value? 1.5, 1.7. Can you say like that? No. Because one person means one full person. Two people means two full people. You cannot have any decimal value or any integer values there. That is why it is called a discrete value. And the number of households, like one person is living in how many? How do you explain it? So number of the size of household with the number 1, 2, 3, 4, 5. So the number of households which has only one person living in it is only 5. Whereas where two people are there, then it is 50. We are not talking about who are those people. We are talking only about the number. That's why it's quantitative variable. Okay, when you talk about whether it is a male or a female, then it will go as a qualitative variable. We are talking only about quantitative variable. That is 5, 15, 20. How many number of people are in that particular house? That is the size of the household. Here, these numbers are there, right? This is called a frequency array. There is no number of observations. Is there like number of observations? You have a class from 10 to 20. How much? No. One person lives in how many households? 5. That's it. Direct. The variable size of the household is a discrete variable. Why is it a discrete variable? Direct jumps are there. There are only integral values, no integers, no fractions are there. Fine. This is all about frequency distribution. The final topic in this organization of data is called as bivariate frequency distribution. Okay, so far we have discussed what is frequency distribution, how do you prepare a frequency distribution, classification of data, and all those things. Finally, we are going to talk about bivariate frequency distribution. That is same frequency distribution table with two different variables. And two different variables, bi means what? Two. Variate means two different variables. Information related to two different elements. Okay, then they are called as bivariate frequency distribution. Okay, what happens in this bivariate frequency distribution? What it is? Very often when we take a sample from a population, we collect more than one type of information from each element of the sample. That is, example is given 20 companies from the list of the companies based in a city that we collect on sales and expenditure on advertisement. So for example, when we talk about you go to a person, okay, you are talking about their likes and dislikes, whether they prefer coffee or tea. Okay, the first question is about coffee or tea. Second thing, you ask which kind of coffee or which type of coffee do you drink. That will become bivariate. When you study about two different elements, in the example that they have given to you, they have studied about the expenditure that is done on the sales and what they have given on the advertising. How much sales have been incurred there, only for what value the sales is done and for what advertisement expenditure is incurred. When they want to relate it and study. Here what is the relationship between sales and expenditure, sales and advertising expenditure? Because if the advertising expenditure is spent more and if the sales has increased, then they'll study that the advertising has some impact towards the sales. Whereas if there is no relationship, even though the sales was the same, advertising was of too reaching it, it was not at all reachable, the sales did not increase, then what is the problem they will analyze. For better analysis, when they want to relate two different variables and discuss about it, they go for a bivariate frequency distribution. So it can be defined as the frequency distribution of two variables. What is it? It is the frequency distribution of two different variables. So in the example that they have given to you, it helps you, right? As a firm, when you sit as a sales and marketing manager, you can see that how the sales was there any impact on the sales due to advertising. So they have given you as a table, this frequency distribution looks different. How does it look different? In x-axis, y-axis, your marking, right? Same way. The choice of both are talked about here. So one side they have the sales, on top they have given the sales expenditure. I'm taking only few values, student, for understanding. Okay. On the other side, they have spoken about the expenditure that they have incurred. Like this it is there. Means they have given you value like this. 2, 1, 1. What does it mean? How do you understand it? What do you mean by this particular thing means? You have to study it in this way. See, there were two firms which sales who have come across sales of 110 to 120 crores. Can be anything. 110, 112, 113. Again, there we will go with class. That was a different frequency distribution. Here, this is about expenditure incurred on advertising. So these two firms are there, right? Company X and company Y. They have spent somewhere from 62 to 64 crores for sales, or for rupees, lakhs or thousands, however you take, 62 to 64,000 for advertising, and they have done 110 to 120 crores of sales. This is common. Both has to apply. Have to take it like this. Okay. Same way when you talk about that particular column, 64 to 66,000 rupees of advertising expenditure and 130 to 140 crores of sales has been done means they need to mark that particular column. So as you do this tabular column, you will understand this. When you talk about this two, vertically it means with 120 to 130 crores of sales. Okay, this is sales. Whereas horizontally it needs 66 to 68 thousands of advertisement expenditure. So both these companies have incurred, both they have incurred this much of expenditure and they have sold for this much of value. This helps you, this bivariate frequency distribution helps you to study about two different variables using one particular frequency distribution. Okay, this is what is given. This is studied in detail in chapter 8. We will be discussing this detailing in which chapter? In chapter 8, which is going to be correlation. How you are going to correlate it, how you are going to understand this. We are going to study it detailing in the next topic. As of now, the organization of data, chapter 3 is completed. What are the various things we have discussed, children? That is raw data. Understanding raw data or getting data or getting information from raw data is very difficult. Hence what do? We have to classify the data. On what basis you classify? On the basis of time, place, on the quality or on the basis of quantity, which are called as chronological classification, spatial classification, quantitative classification and qualitative classification. And these are done. Fine. What do you do next? You go for the next step, which is the frequency distribution. What is frequency? How do you calculate it? We spoke about continuous and discrete variables. Then how do you prepare this frequency distribution? By determining 5 different things. Whether you want to have equal or unequal size class intervals, how many number of classes you want to have, what should be the size of the class, what is the upper class limit, lower class limit, and finally, what was the final thing that we have discussed? We have discussed about the frequency. How do you determine the number of frequency? For continuous variables, you will use the tally marking system. You have to do the adjustment in class interval. And finally, we spoke about frequency array, which is related with discrete variables. After that, what did we discuss? We discussed about the bivariate frequency distribution. A frequency distribution of two variables is called as a bivariate frequency distribution. When you are studying, when you are using the same sample, when you are discussing about two different elements, advertising is one element and sales is another element. When you study the income and expenditure, two different elements, how much you earn and how much you spend, two different elements. Okay, you can study about it in a common frequency distribution table, which is called the bivariate frequency distribution. This will be dealt in depth in chapter 8, which is going to be correlation. Okay, so I hope you have understood the next step in the data collection. Like we have collected data, next we have classified data also. I want you to work out those problems even in your exercises. Okay, we have problems like 5th question is a problem, 6th one is a problem, 10th one is a problem, and even 11th one is also a problem. I want you to use these 4 problems in your classwork. Okay, I want you to work out these 4 problems in your classwork, and of course if you have a doubt, please feel free to reach me out. In the next session, we are going to start a new chapter, which is going to be presentation of data. But before that, go through this video clearly, understand the worksheet, read it properly, answer all the questions. Please don't miss any questions. Along with your worksheet, I want you to jot down the notes, whatever I have taught, extra points and all those things of your understanding. And of course, compulsorily the problems have to be worked out in your classwork note. Right, children? So thank you, and meet you in the next video session. Thank you, and you all have a wonderful day.